Hello, this is Charlene. In this video, we're going to talk about the basic concepts of probability. Let's read through some of this material and then we're going to go back and talk about it more in depth. An event is any collection of results or outcomes of a procedure. The sample space S for a procedure consists of the collection of all the possible outcomes. Let's consider the probability of rolling a single fair die. When we have a die, we have 6 sides. We can either roll a 1, a 2, a 3, a 4, a 5, or a 6. And those are all of the outcomes. The outcomes are the 1 or the 2 or the 3, etc., all the way up to the 6. And we've already counted those on our sides. We also have the set of all possible outcomes forms the sample space. So for rolling this 6-sided die, we have a sample space that includes the 1, the 2, the 3, the 4, the 5, or the 6. That is all of the possible outcomes. We cannot get any other number when we roll a 6-sided die, just 1, 2, 3, 4, 5, 6. So that is a set of all possible outcomes. And then we have this event E, says event E is rolling an even number. So I assume that they are using the letter E because we're talking about even numbers. Well, what are the even numbers out of our sample size? Our sample is 1, 2, 3, 4, 5, 6. But the only even numbers are 2, 4, and 6. So event E has a sample size of 3 elements, 2, 4, and 6. But let's go back and talk about this a little bit more. An event is any collection of results. So the thing is, though, is that event E is this collection 2, 4, and 6. But what if we said event A is any? What is the event that we would roll any number? Well, that is going to be represented by 1, 2, 3, 4, 5, 6. So event A is going to be the collection of all of our options. Any number would be 1, 2, or 3, 4, 5, and 6. But event E is just going to be the collection 2, 4, and 6. So an event can be any collection. It can be 6 options, possible outcomes. It can be 3 possible outcomes. It could possibly even be just one outcome. For instance, you could say, what is the event where we could roll a 2? Well, that would be the collection containing only a 2 because there's only one outcome that can give us a 2. A simple event is an outcome or an event that cannot be further broken down into simpler components. Or another way of looking at this is that a simple event example is like rolling a 2. There is only one way to satisfy this event, or there is only one possible outcome. So a simple event has only one possible outcome. Event E, such as rolling an even number, has 1, 2, 3 possible outcomes. It has 3 different ways to satisfy the event of rolling an even number. So that means that an event E has more than one possible outcome. So it is not a simple event. Something that is also not a simple event can also be called a compound event because it combines 3 different simple events. The event of rolling a 2 is a simple event. The event of rolling a 4 is a simple event. The event of rolling a 6 is a simple event. But event E has 3 simple events combined, and so that makes it a compound event and not a simple event. Now we need to stop and make some important notes about probability in general. So, probability is always about parts in relation to a whole or parts in relation to a total. Like, for instance, this little wheel here, it looks like a pizza. We could talk about one slice of pizza. Well, how many pieces of pizza does the entire pizza have in it? Well, it has 8. So we can think of that as being one part out of 8 whole pieces, or one part out of 8 total pieces. And but we can talk about 2 pieces or 3 pieces or 4 pieces, et cetera, et cetera, et cetera. So the thing is, though, is that we need to understand that on our handy dandy calculator, these can all be fractions. These are all 1 out of 8, 2 out of 8, 3 out of 8, 4 out of 8, 5 out of 8. Of course, we can have 6, 7, or 8 pieces of pizza. And these are all fractions. These are all fractions. And we can convert all of our fractions to decimals, to decimals. But all of these numbers occur between 0 and 1. The biggest number that we can have is 8 pizzas, or pieces of pizza out of 8 total pizzas, which would be one whole pizza. So 8 out of 8, 8 pieces out of 8 pieces would be one whole pizza. But all of our probabilities with respect to this pizza are going to be between 0 and 1. So all of our probabilities are going to be between 0 and 1. Now, it could be equal to 0 because we could have 0 pieces of pizza. We could have eaten 100% of that pizza and it's all gone, and we would have 0 pieces of pizza out of 8 left. So it can be equal to 0 pieces of pizza, but it could also be equal to one whole pizza that nobody has eaten. So that can also be equal to the 1. But the main idea is that all probabilities will be between 0 and 1. All of them. So this is going forward. This is just essentially important that you understand that all of your probabilities will live between 0 and 1. They will be represented as a fraction, or they will be represented as a decimal unless they are actually equal to the 0 or the 1. Okay, always express a probability as a fraction or a decimal between 0 and 1, and that's what we already stated previously. The probability of an impossible event is 0. What does that mean? Well, can we roll a 7 on a 6-sided die? Well, no, it is impossible to roll a 7, so the probability will be equal to 0. There is 0 chance that we can roll a 7 on a 6-sided die. The probability of an event that is certain to occur is 1. Okay, so I have odd numbers on a 6-sided die, and I have even numbers. So what is the probability that I will roll either an odd or an even number? Well, I've got odd, even, odd, even, odd, even. So 100% of my choices are odd or even. So the probability is equal to 1, because 1 is equal to 100%. The probability will be written as something between 0 and 1. But the 1 means one whole pizza means 100% of that pizza. So the probability that something is certain will be equal to 1. For any event A, the probability of A is between 0 and 1 inclusive. That word inclusive is talking about this equal sign. The fact that our probability can be equal to 0. If we've eaten all the pizza, then 0 out of 8 pieces are left. So the probability can be 0. It's also the fact that it's something that's impossible. And our probability can be equal to one whole thing. Like if all of our choices are either odd or even, then that means my probability is equal to 1 because 100% of my choices are equal to odd or even numbers. Okay, and here we talk about the sum. The sum of the probabilities of all outcomes for any particular event must total 1. So what does that mean? If I have 8 pieces of pizza here, what are the chances that somebody is going to give me this pizza? Well, there's one piece of pizza out of 8 choices. So the probability for that first piece of pizza is 1 out of 8. But what is the probability that they will give me this pizza? Well, it's still 1 out of 8. So for every piece of pizza, I have one chance to get that piece of pizza. If I add up all of those 8 pieces of pizza and the chance of getting each of those pieces of pizza, they will equal 1. They will total and add up to 1. Same thing for my 6-sided die over here. It's like, what are the chances of getting a 1? Well, it's 1 out of 6. What are the chances of getting a 2? Well, 1 out of 6. What are the chances of getting a 3? And what are the chances of getting a 4, et cetera, et cetera, et cetera? Well, each one of those is a 1 out of 6 chance. So if I add up all of my probabilities, they will total 1. So it's important to remember that the sum of all the probabilities of any particular event must total 1. Add up to 100% of all the possible outcomes. P of E is how we write probability of event E occurring. We're going to talk about 2 types of probability. The first one is classical or theoretical probability. Theoretical probability is used when each outcome in a sample space is equally likely to occur. Just like when we did the 6-sided dice, we had 1/6 chance and a 1/6 chance and a 1/6 chance, et cetera, et cetera, et cetera. Each one of them had an equal chance, 1 out of 6, 1 out of 6, 1 out of 6. Same thing for the pizza divided into 8 pieces. Every single piece had a 1 out of 8 chance of being chosen. Okay, so the theoretical probability equation, generally speaking, is number of ways that event E can occur out of the number of possible outcomes. So again, like we talked about earlier, it's always about a part out of a total number of possibilities or total number of outcomes. But the thing with the theoretical probability is that this is a general expectation. The second type of probability we're going to talk about is the empirical or statistical probability. It's based on observations that are obtained from probability experiments. The way that we write its or describe its formula is that the probability of an event happening is a relative frequency of E. And specifically, it's the frequency of event E divided by the number of trials of the experiment. So it's slightly different. So we're going to have frequency divided by some total number of frequencies. But again, it's still going to be about a part divided about a total number. So that's still the bottom line when it comes to probabilities. But this empirical or statistical probability based on experiments is using actual data. It is not a general expectation. It is going to be a real expectation based on actual data. Subjective probability of an outcome is a probability that's obtained based on personal judgment. For example, an economist must use their knowledge of the current condition of the economy, and they will make an educated guess about the likelihood of a recession. So the subjective probability is essentially an educated guess, but there's a certain amount of reliability because we expect the economist to have knowledge of the situation and be able to make a reasonable projection about the probability. Okay, so let's practice classifying probability. This says that we want to determine whether the probabilities are computed using classical methods or empirical methods or subjective methods. So our first problem says the probability of having 8 girls in an 8-child family is 0.00390,625. Okay, so how did they come up with that number? Did they use classical methods, empirical methods, or subjective methods? So the subjective method over here, this is the educated guess. So I'm assuming we're not giving any information that somebody made an educated guess. So I'm going to go ahead and reject that one as an option. But we need to consider whether it was classical or theoretical probability, which has to do with equal chances. Every single option would have an equal chance compared to the other outcomes. And then we also have empirical or statistical probability, which is based on frequency based on experiment with actual data. So an experiment with actual data could be like a survey. They could ask the family, do you have 8 children? Are all 8 of your children girls? And they could have so many families that said, yes, we have 8 girls. And they could come up with some information like that, but they were not told that they asked the families. So I'm assuming that we can also reject empirical because we do not have any information that they actually asked the families about how many of their 8 children were girls. But let's go ahead and we want to see if we can confirm this number by using classical or theoretical probability. So every time you have a child, like the first child, there is a 1 out of 2 chance. There's two options. It could be a boy, it could be a girl, and there's a 1 out of 2 chance that the first child could be a girl. Well, when you have the second child, completely independent of the first child, you still have a 1 out of 2 chance of having a girl. And you would go ahead and repeat that all the way down up until the 8th child, and you still have a 1 in 2 chance of having a girl. Okay, so that means that we could um, multiply all of those. Okay, so I converted my fractions to decimals to 0.5. So basically it's like 0.5 times 0.5 times 0.5 times 0.5 times 0.5, la la la, et cetera, et cetera, et cetera. However, we can use the shortcut because this is like 1, 2, 3, 4, 5, 6, 7, 8 factors of 0.5, which means that we can actually write that as 0.5 to the 8th power. So that would be the way that we would write this. All of these being multiplied times each other is 0.5 by a factor of 8. I could put it in my calculator like this, and it is going to give me this answer, 0.00390625, which does match with this. So this indicates that we have used the classical or theoretical probability method to calculate the probability of having 8 girls in an 8-child family. And of course, we need to remember that when we're using classical or theoretical probability, that these are general assumptions about this, the general assumptions. These are not absolute based on actual data. These are general assumptions. Okay, our next situation says based on a survey of 1,000 families with 8 children, the probability of a family having 8 girls is 0.005. Okay, so this is based on a survey. So that is our key word right there. That means that we can assume that this is a frequency-based probability um, on an based on an experiment with actual data. They did a survey and they have actual data. So, and they actually tell us here that the probability of having 8 girls is 0.005, which means we can actually write that like this. We can say the probability of 8 girls is equal to 0.005. Okay, so based on our information earlier in this video, we are going to use these formulas right here. Now, this one just says that the probability is approximately a relative frequency of the event, but the particular formula is the frequency of event E um, divided by the number of trials of experiment. Okay, so what does this mean? Number of trials of experiment. Well, that's literally the number of people in the sample, the number of people or families that they asked. They asked and they told us that. They told us that it was a survey of 1,000 families. So that means that our sample was equal to 1,000 families. And that means that the number of trials is equal to 1,000. That's this giving us the same exact information. So that means that we can take this little piece right here, the frequencies divided by the summation of the frequencies. Well, the number of trials of the experiment in symbolic math language is written as the summation of the frequencies, and this is also telling us that is the sample size, that is the survey size. So that means that we could actually write this as the frequency divided by the 1,000 families. So this frequency is going to represent literally the actual number of families that have 8 girls. And they told us that the probability of 8 girls is equal to this number. So that means that this equation is also equal to the 0.005. So that means we can actually figure out exactly how many families had 8 girls out of 8 children. So how can we do that? Okay, so I've got it here. I know that my summation of frequencies is the same thing as the number of trials or the sample size, and I can set that equal to each other, which I already did. Then down here, so here we go. We're just going to keep solving it. We're going to use our algebra skills to solve it. So I can take both sides and I can multiply both sides by 1,000. So this fraction, this ratio here, is going to be multiplied by 1,000 because that allows me to cancel out the 1,000. But if I do it to one side, then I have to do it to the other side. So then I'm going to do 1,000 times the 0.005, and that is then going to let me solve for the frequency, which is the number of families that actually have 8 girls out of 8 children. And what is 0.005 times 1,000? Well, let's put it in our handy dandy calculator. And our handy dandy calculator says, oops, a little bit too big there, that there were 5 families who actually had 8 girls out of 8 children. So 5 out of 1,000. 5 out of 1,000 actually have 8 girls out of 8 children. So the question was basically they just wanted us to find out whether we were using classical, empirical, or subjective, and this one was a survey. So the answer to the question is definitely empirical or statistical probability because it was using actual data, but we were able to take it even further and figure out how many families actually have 8 girls out of 8 children. Okay, our next question says, according to a sports analyst, the probability that the Chicago Bears will win their next game is 0.30. So this is definitely the educated guess. We have a sports analyst. This is what he does for a living. He looks at all the numbers. He looks at all the competition. He looks at all their statistics, and he can make an educated guess. So if he's making an educated guess, then the probability method here is the subjective probability method. Okay, the next one says that we are basing this on clinical trials. The probability of efficacy of a new drug is 0.75. So we're talking about clinical trials. That means that we're doing experiments. And so that's going to be a frequency based on experiment, and they're going to come up with actual data. And that means that they are using the empirical or statistical probability method to come up with this number. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.